Hello, this is lesson 10, the last lesson in the series of 10 lessons where we were learning about the volume of different shapes. And in this lesson 10, I want us to do a revision using different questions which relate to volume of different shapes. So, can we start? We can start with this question here, which says a cuboid has the length of 10 centimeters, width of 8 centimeters, and height of 6 centimeters. Work out the volume of the cuboid. And we said volume is the total space occupied by the given shape. And in our case, the shape is a cuboid, so our volume is the total space occupied by that cuboid, like that. So to get the volume of a cuboid, we said volume V is given by length multiplied by width multiplied by height. But you see, we are given the length as 10 centimeters, then the width is 8 centimeters, and then the height is 6 centimeters. So, to get the volume, you need to take volume V is equals to length, which is 10 centimeters, multiplied by the width, which is 8 centimeters, multiplied by the height, which is 6 centimeters, like that. Then from there, I can take 10 multiplied by 8 is 8, then multiplied by 6 is 408. So volume will be 408. But you see we have centimeters here, and centimeters here. So we need to also multiply them. So it will be, if I take, for example, x, I multiply with another x, then I multiply with another x, it will be x cubed. So the same case here, if I take centimeters, I multiply with another centimeters, and I multiply with other centimeters, like that, 1, 2, 3, it will be centimeter cubed, like that. So this centimeter multiplied by this, it will be centimeter cubed. That becomes the solution for this question here. That is the volume, 408 centimeter cubed. Can we try another example? So in this one, you are told a cylinder has a radius of 5 centimeters and a height of 14 centimeters. Calculate the volume of the cylinder. Give your answer in terms of pi. So, of course, we said volume is the total space occupied by the given shape. And in our case, the shape is a cylinder. So, volume is the total space occupied by that cylinder, like that. And we have the radius of the cylinder, which is 5 centimeter. So radius R is 5 centimeters. And then we also have the height, which is 14 centimeters, like that. And then from the previous lessons, we said volume V of a cylinder is given by pi R squared, which is the surface area, and since a cylinder has a surface area of a circle, then it means that a surface area should use the formula of a circle to get it, which is pi R squared. Then we multiply with the height now to get the volume. So from there, we are taught to give the answer in terms of pi. So then it means volume V will be equal to pi multiplied by R squared, and we know R is 5, so it is 5 but now squared, then multiplied by 40. We multiply by 40, like that. So it becomes volume V is the same as pi, then 5 squared is 25, then multiplied by 14, like that, which now becomes 25 multiplied by 14 is 350, then pi and centimeter cubed, and that becomes the volume for this cylinder here. Let us try another example. In this question here you are told the diagram shows a triangular prism. The cross-section is a right-angled triangle with the base of 8 centimeters and height of 6 centimeters. The length of the prism is 10 centimeters. Calculate the volume of the prism. How we said, because this is a triangular prism, and to get volume, we first of all need to get the cross-sectional area. And in this case, because it is a triangle, then it means we need to first get the cross-sectional area, which is a triangle. So area of a triangle, then we multiply by the length to get the volume of that prism. And the volume we are talking about is that, then the cross-sectional area we are talking about is this one. There's two triangles. So to do so, we already have the base of the triangle, which is 8, and height is 6. So base, we set it here, base is 8 centimeters, then height is given by 6 centimeters, like that. So we already know the area of a triangle A is given by half base multiplied by height. But we already have the base and the height. So it will be half of the base is 8 centimeters, then the height is 6 centimeters. So then it will be, divide this 1 by 2, 1 by 2, 4, because 8 divided by 2 is 4, then 4 multiplied by 6 is 24. So it becomes 24 centimeters squared. But this is the cross-sectional area, it's not the volume. Now the volume will be given by the cross-sectional area, let me call it CA, the cross-sectional area multiplied by the length of that prism. So we already know the length L of the prism we are given here is 10 centimeters. 10 centimeters. So now the volume V will be equal to the cross-sectional area, which is 24 centimeters squared multiplied by 10 centimeters, like that. So volume V will be equivalent to 24 multiplied by 10 is 240. And you see we have centimeter squared here. Then we multiply with an extra centimeter. It will be the same as multiplying x squared multiplied by another x. It will be x cubed. So the same case here, centimeter squared multiplied by an extra centimeter there, it will be centimeter cubed. So this one's multiplied by this centimeter here, it will be centimeter cubed, and that becomes the volume of this prism here. So can you try the last question? So in this question here you are told the diagram shows a prism with a trapezium cross-section. The parallel sides of the trapezium are 12 centimeter and 6 centimeter. Then the perpendicular height of the trapezium is 5 centimeters. Then the length of the prism is 9 centimeters. Then work out the volume of the prism. And since this one has a cross-section of a trapezium, of course we need to find the cross-sectional area, which now in this case is the area of the trapezium. Then we multiply by the length of the prism to get the volume. So those are the two trapeziums, and then the volume you are looking for is the total space occupied by that prism, which is that one. So we said from our previous lessons, we said the cross-sectional area, I can just call it A, of a trapezium is given by half into A plus B, like that. Then multiplied by the height, where A and B are the parallel sides of the trapezium. So I think we are given all of them. We are given A, we are given B, and we are given the height. Let us see. Which the hair is of course 12 centimeter, B 6 centimeter, and H is 5 centimeter. So now the cross-sectional area M becomes a half of A, which is 12, plus B, which is 6, then multiplied by H, which is 5. So it becomes 12 plus 6 is 18. So now it becomes half of 18 multiplied by 5, which becomes half of 18 is 9, then multiplied by 5 is 45 centimeters squared. But that is the cross-sectional area. It is not the volume of the prism. So to get the volume V of the prism, we need to take the cross-sectional area. I can just call it C here, cross-sectional area, multiplied by the length of that prism. And in this case, we are given the length of the prism as 9 centimeters. So L is 9 centimeters. And we already have the cross-sectional area, which is 45 centimeters squared, then multiplied by 9 centimeters like that, which now becomes 405 centimeter cubed. And that is the volume of this prism here. So that marks the end of this series where we were exploring the volume of different shapes. So if you have any question or there is a place you did not understand, you can ask me in the comment section. I'll try my level best to answer. And let us meet in a new series where we will be exploring different mathematical concepts. And bye for now.